Hey everyone, and welcome back to the channel. I'm Dan, and I'm excited to be kicking off a new episode today. Today we're diving right into a powerful Python library called Pydantic. Before we jump into the code, let's take a quick moment to chat about what Pydantic is and where it came from. Understanding a library's background can really help you appreciate its purpose and power. So, buckle up and let's explore Pydantic together. Let us head over to the Pydantic homepage. Pydantic is an open source library that acts as a powerhouse for data validation in Python. The project actually started back in 2017 by Samuel Colvin. Since then, it's become incredibly popular, boasting over 100 million downloads every month. That means most major companies worldwide are using Pydantic behind the scenes. And get this, the core of its recent V2 release is lightning fast, thanks to being built with Rust. Plus, Samuel Colvin recently secured funding to develop cloud services based on Pydantic. Pretty exciting stuff, right? One more thing to remember about Pydantic. It has fantastic documentation. This documentation dives deep into all the functionalities Pydantic offers, providing clear explanations and numerous code examples. So, if you ever find yourself stuck during development, don't hesitate to turn to the Pydantic docs. They'll be your best friend, guiding you through the library's features and helping you overcome any challenges you might encounter. So, are you curious to see how Pydantic can help you? Let's get started with the code. For those following along with the code, you'll find the link to this project on my GitHub page in the description below. Now, to get started, we'll need to install all dependencies. In this case, it is only Pydantic. Use the poetry install command to install the dependencies. If you're new to managing Python dependencies and haven't heard of poetry, be sure to check out my previous video that walks you through setting up your environment for success. In our first example, we'll showcase the base functionality of Pydantic. To start, we'll import the base model class from Pydantic. This base model is the foundation upon which you build your data models, essentially defining the structure of your data. We define a user class with attributes ID and name. The type hints indicate that the ID must be an integer and the name a string. Pydantic uses the type hints to automatically validate the input values for every new instance of the class. Let's create now a user with ID 1 and name Dan. The user is successfully created. The provided data matched the expected data types. Now, let's create another user. But this time, we'll swap the ID and name values. You can see that Pydantic raises a validation error, specifically mentioning that the provided value for ID is not an integer, and the value for name is not a string. This clear error message helps you pinpoint the exact issue, the wrong data type for the ID and name attributes. This immediate feedback ensures you catch errors early on and maintain the integrity of your data. All right, everyone, that's it for the core functionality of Pydantic. You've now seen how it acts as a data validation powerhouse, ensuring our information stays clean and organized. But remember, this is just the tip of the iceberg. Let's move on to the next code example. Here we'll explore defining more complex data types within our Pydantic models. These types allow you to represent richer information compared to basic data types, like integers and strings. To achieve this, we'll need to import two modules from the Python's base libraries, datetime and enum. The datetime module provides classes for working with dates and times. The enum module allows you to define enumerated types, which restrict the allowed values for specific attributes. We'll see how these modules can be used with Pydantic's base model to create more flexible and powerful data models. First, we'll create an enum class called role. This enum will represent the different roles a user can have within a system, offering 3 levels: reader, editor, and admin. Next, we'll define a location class inheriting from Pydantic's base model. This class will act as a blueprint for representing user locations. Within the location class, we'll define 2 string attributes, city and country. We enriched the user model from the previous example with several attributes. We defined an attribute of type datetime to capture the date and time the user was created. The user's permission level can be specified with the role enum. Team members are represented by a list of integers containing the IDs of the teams the user belongs to. Finally, an optional location attribute of the location class allows us to store the user's city and country information. With the Pydantic model, you can now create user instances with automatic validation. If any of these checks fail, Pydantic throws a validation error pinpointing the exact issue. This immediate feedback helps you catch errors early on and ensures your complex user data remains consistent and reliable. While we've covered some of the built-in data types, it's important to remember that Pydantic supports many more for validation. For the full list and all the exciting ways to use them, be sure to check out the Pydantic documentation. In this final example, we'll dive into the world of serialization and deserialization with Pydantic. Serialization is the process of taking your data in a Pydantic model and transforming it into a format that can be easily stored or transmitted. Imagine packing your neatly organized clothes, the data, into a suitcase, the serialized format, for a trip. Deserialization is the opposite journey. It's unpacking that suitcase and turning the stored data back into a usable Pydantic model, ready to be accessed and manipulated. With Pydantic, you can easily switch between these two states, making it a powerful tool for managing your data, especially when dealing with databases or API interfaces. These functionalities are crucial for efficiently interacting with external systems and ensuring data integrity. Let's have a look at the code. We take the simple user model from the first example and create a user instance. Pydantic comes in handy when we want to prepare this user data for other systems. By using the model dump method, we can transform our user object into a regular Python dictionary. This dictionary holds all of the user information in a format that external systems can easily understand. This makes it a breeze to send data to databases, APIs, or any other system that needs to access it. With Pydantic's serialization, sharing user information becomes efficient and streamlined. Imagine now we receive a data package from an external system containing user information. This data is in a dictionary format, as you can see it here. We use the double asterisk operator to unpack the dictionary and pass its key value pairs as keyword arguments to the user model. Pydantic recognizes these arguments and uses them to create a new user instance. Essentially, we're unpacking the data package and building a corresponding user object within our system. This deserialization process allows us to seamlessly integrate user information received from external systems with automatic data validation. And that's a wrap on serialization and deserialization with Pydantic. We've seen how Pydantic seamlessly transforms data into transferable formats and efficiently brings it back for internal use. With these superpowers, you can confidently manage data exchange between your applications and external systems. That's all for today. We've scratched the surface of Pydantic's capabilities, and hopefully you're curious to see what else it can do. We'll be diving deeper into its functionalities in upcoming episodes, so stay tuned. If you enjoyed this introduction, be sure to give us a thumbs up and subscribe for more. See you next time.